So let's try to share the screen if it allows me to share the screen. Yay, we're sharing the screen. Okay, so we're trying to solve this easy level problem. Easy level problem. New managing moderator, close. Easy level problem. Whenever I'm down. Easy level problem. So we're looking at what? Find the highest altitude. So this is a random problem, but not completely random. It's from my club, from a group that is practicing solving algorithmic problems. I picked the easy one just because I feel so, and because it's all on a fluke. To practice, this is to practice solving it real time. And let's see. So there are there are two options. Some problems are not interview format, so they're like too long. The solution is too long, and so forth. Hopefully, this is more of an interview format, but we'll see. So there is let's start. So there is a biker going on a road trip. Wonderful, wonderful. The road trip consists of n+1 points at different altitudes. n+1. The biker starts his trip on point 0 with altitude equals 0. You're given an integer array gain of length n, where gain I is the net gain. What means is the net gain in altitude between points I? Net gain for all, return the highest altitude of a point. So there could be net, okay, it could be, let's look at an example. Yeah, I don't really clearly understand what net gain is. Okay, so at 0 altitude equals 0. Okay, but then we have so output, and we need to return the highest altitude of a point. So any point, what was the highest altitude? Okay, let's see. So we'll have in this example -5. So what that means, on this road, the net gain is -5. -4. The highest is 1. I don't exactly understand. I'm like, feel so stupid now. With altitude 0 is the net gain in altitude between points I. Okay, so between 0 and that point, the net gain is -5. The altitudes are. Okay, oh yeah, so wait, hold on. This is the input, and this is what happens to the altitude. So we were at 0, then we are at -5 because you deduct 0 minus 5. Then -5 plus 1. So it looks like what's happening is it was 0, then 0 minus 5, it became -5. Then -5 plus 1. Yeah, so it's like -5 here. Plus 1 is -4. Then -4 plus 5 is 1. Then we have 0, and then we have -7. So that's the highest point. Well, it looks like we need to get that number and track the maximum out of these numbers, compare it to our maximum. And we'll have a result. We'll initialize it at minus. Well, we can initialize it at what can we initialize it at? We know it's 0, so in the first one is 0. Yeah, well, I guess we can initialize it at 0. So that's largest. Let's max out. Yeah, let's name it more clearly. And then we're going to iterate over these altitudes. And by the way, we need to track the current altitude. Current altitude is going to start with 0. So we're going to loop over the values. Range gain. We don't care about the indices. So as we see so we have a value v, and current altitude is updated with v, and we need to update update max or run max altitude against. Altitude is max out of max alt and current alt. I think that should do it. I think that should do it. Because return max altitude, max altitude. So why should that do that? Max is 0. The first one, because you see, if we use the initial altitude, the starting point is 0, with altitude equals 0. Yeah, so with this altitude, if this is the maximum that we will ever get, then we just, then we'll return that. Yeah, what if the trip is all going downhill? Now, we have, let's check out the constraints just in case. Okay, so n is the length of this gain array, and there is maximum of 100 values in that array, at least 1, and up to 100, and the values are at least minus, yeah, from minus 100 to negative 100 to positive 100. Okay, so that should be working. Let's test run it. Yay, it works. So let's run the full test. Yay. So what is the, I mean, in this problem, it's a nice little warm-up problem. What are we looking at? I mean, what are we doing here? We are initializing the variable that will track the maximum altitude. And since the initial altitude is 0, we can set it as 0. Then we will be tracking current altitude. It will be adjusted at every gain value. So to do that, we'll just loop over the gain array, but it's slice in Golang. And that's pretty much it, I think. That is pretty much it. I mean, then yeah, and then we compare the max, the current altitude and the maximum altitude so far, and we get the maximum altitude. Yeah, we need to we check if we need to update the maximum if it's bigger than the current maximum, than the maximum so far. And then we'll return the maximum altitude. Okay, so that's what we have here. Now let's try to tackle some other problem. Find the count of. Yeah, so there is a hard level problem. And I think I need to reshare it. Why am I leaning to the side? I don't understand. It's my first time streaming, second time streaming. Interesting. So first time streaming, second time streaming. Let's share the other problem. Let's just check it out. Let's see if we can get it, because I have like 30 minutes till our meetup where we'll review these solutions. So am I sharing? Yay. So this is a hard level problem. I have no idea if it's interview format or not. I mean, I can just sneak into the solutions and see but sometimes those solutions are not, well, there could be a variety of those. So at least what I like, there is just there's one argument that's coming in to the function, count of pairs. So not 100, that's good news. And the description is almost 1 page. So yeah, it's like 1, 2, 5, 6 lines. So we'll see if I can try to understand the problem at least. And maybe have some ideas for some solutions and what the topics are here. In the previous problem, the topics were there were just it was a basic loop over with comparisons and tracking the maximum. So in this, we have find the count of monotonic pairs. 1. Okay, so level 1, monotonic pairs. You're given an array of positive integers nums Okay, I understand that. Positive integers, nums. They're all positive and they're integers of that length. Okay, we call a pair of non-negative integer arrays monotonic. Monotonic, am I pronouncing it? Monotonic. Monotonic. Yeah, so monotonic if the lengths of both. Okay, so if, and there is several conditions, like 4 conditions. Okay, first condition, the lengths of both arrays are n. What? A pair of non-negative integer arrays. Oh, wait a second. So we're talking about pairs of arrays, not pairs of numbers. Non-negative integer arrays, 2 arrays, monotonic. Okay, they have the same length. Okay. Array 1 is monotonically non-decreasing. In other words, yeah, that's a good representation. So they're not decreasing. It's at least, the next value is at least the same size or higher. And then, but the array 2 is monotonically non-increasing. So there are different directions. Just to give a reminder, give myself a reminder of what that is. So if that's 0 level, so we have that. Non-decreasing could go, then it will go, for example, what is this, like that? Could increase, then continue like that, and it could be just increasing all the way next times, like then let's say increase and some more increase. Yeah, so that's not non-decreasing monotonically. Okay, so one of the first one is non-decreasing, the second one is non-increasing. And oh, wait a second, I need to restart the clock. Oops, I did it again. I forgot to restart the clock. Recount the count of monotonic pairs. So, okay, wait a second. Yeah, I lost where I was reading. So, and what else? The third condition is that, okay, ith value in first array and ith value, if we add it to the ith value in the second array, we get nums I. So that the input array, the sum for all i's, for all the values from 0 to, so for all the values, the sum of them, okay, so yeah, they are together, they form the value in the nums. Return the count of monotonic pairs. Since the answer may be very large, return it modulo. Okay, that sounds scary. I don't understand what that is. Return it modulo. Modulus. Oh yeah, it is scary. My fear is justified. The two numbers are congruent modulo a given number if they Chiwis. Modulo. I need to ask Gemini how to, okay, what that means. I mean, I kind of understand. So since the answer may be very large answer, number of monotonic arrays. What do you mean? Done. So explain this. So yeah, let me just ask the question. Okay, and then return the remainder when the number is divided by that number, that 10 to the power of 9. So it's, is it a billion? Yeah, it's a billion plus 7. This process is called taking the modulo of a number. Here is why we might do this. Very large numbers. When dealing with extremely large numbers, computers can struggle to store and manipulate them accurately. Taking the modulo can help to reduce the size of the number while representing its essential properties. Oh, return it modulo. So what, I mean, I know what modulo is. It's the modulo typically, it's the remainder division. So it's 5 modulo 2 is 1. So that's the remainder. I think that is that. That's what I think. Oops, very large numbers. When dealing with extremely large numbers, computers struggle. Modulo can help to reduce the size of them. And return the remainder when the number is divided. Okay, so we're talking about the remainder. So what that means, yeah, let's say we have a number that is 10 to the power of 20. Okay. Or let's say like to the power of, yeah, let's say 20. So if we divided, if remainder divided by 10 to the power of 10, so that should give us 10 to the power of 10. But that's the remainder. So that means like if there is like 1, 2, 3, 4, 5, 6, 7, 9, and we divide, so that's to the power of 10. Now, if we divide it by, so let's say to the power of 5. So if we divided modulo divided by, so this thing, yeah, 10 to the power of 5. So that, it should cut off part of it. In this case, it cut off the, it was, what it was, divided by 2, it was 4 plus 1. Yeah, and the remainder of this division will be, yeah, because I don't know, well, it will be this or that. That or this. If we do integer division, we'll get this number of actual 10,000s. Yeah, because there is 50,000. Yeah, there is this number. And that we will lose. That will be decimals, which we will lose. In this case, they're asking about this specific. So yeah, so that remainder, got it. Okay, I think I was focusing on this not essential, not the key point. There was I think it's kind of a minor point, but I just wanted to do it because it's all on a fluke. And on a fluke means especially surprising piece of luck. Random, yeah, it's all random. This all is The stream is random and it's random schedule. That's why. Okay, so but now I understand, yes. I should have thought, but I needed to understand. I wanted to understand that just to get comfortable also. So so let's try to find some key points. Okay, so we have an array of let's look at some tests. So 2, 3, 2, and we know they're all positive. That's good. The length of both arrays are n. Their sum is the num. So the length, the constraints are the length of that input is 2000, and the numbers are up to 50, from 1 to 50. But there is at least one value in the array, 2000. Return the count. I'm curious, could those monotonics be negative? We call a pair of non-negative. Okay, we need to return non-negative integer arrays. Okay, so they are, we count the monotonic. Okay, so for this one, we could get it if we have 0 at plus 2, 1 plus 2, and 1 plus 1. And this one is non-decreasing, and this one is non-increasing. Okay, so if I try to look at it, so one is non-decreasing, that's non-decreasing. The other one is, and they could start at 0, or it could start anywhere, wherever you want. The other is non-increasing, so it could all be zeros, just zeros. And by the way, just zeros also work, but why are they not included? Oh, because the input itself is not monotonic. So if the input was monotonic, by the way, we could just do just zeros on one of the arrays. Okay. Input number. Ooh, and then we'll already have 126. Ooh, okay, 126 variations. Why is it so? Why is it that? So the next one is, so we have this first variation. Then we have the next pair is 0, 1, 2. So this we're increasing that value, and then we're decreasing the last value. Then we're increasing the second value, and then we're decreasing the second value. Then we're decreasing the first, and then we're decreasing the first. Okay, in the second pair. Okay. What's the timing? My drink. Okay. Let's see. So so basically when we add this and that, it has to be in total for this test case 2, 3, 2. I mean, we can start by creating the minimum non-decreasing. So something that's monotonically non-decreasing. Here the minimum, and they just, okay, so it's 1, 1, But I mean, to know that, why does it have to? So it has to be 0, so it can be negative. But why do we have to put 1 here? Okay, because yeah, if we just put 0, okay, that automatically means the other one starts being increasing. The second one is increasing, and the second one cannot be increasing. The second one, I mean, if the second one has to be decreasing. Yeah. So let's take a step back. So how should we approach that? My thinking is I have 2 directions to go here. Overall, one is to try to do to generate these, some generation of this, and then count them. And another approach would be some kind of some kind of math approach without generating and storing and all that values, or just looking at a value, just looking at an array, at a value, calculating how many variations there is. But I mean, I'm curious. I mean, so we generated this, but the question is, how do we know that there is no more? How do we know there is no more? A little stretching, yeah. There is no more to go, because if we have here 2, if we get a 2 and we need the first one non-decreasing, so it has to be at least 3 or 2 the next one. Yeah, if we do 2, we do 3, then it's gonna be it's gonna be decreasing. Okay. Here is the deal. Let's also do another trick. I'm trying to find an approach here, but let's think about a brute force solution, like the worst algorithm, which could do this. Okay. So we could generate a non-decreasing array, all the non-decreasing arrays within that. So we'll see, yeah, we'll just start with 0, 0, and that will be roughly to the power of 2000, roughly. But each number is 50 to the power of 2000. 50 to the power of 2000. That's a big number. Yeah. I mean, if we just brute force this and we generate every possible, yeah, I mean, asymptotically, that is 50 to the power of 2000. That is a big number. Just to give you an idea, I don't know, can I get an idea of myself? Because that's like, that is 5, 10 to the power of 2000. Yeah. So that is a number with 2000 zeros. Now I see why they're saying this may be very large. Okay. Okay. So we have an array. Yeah, who would think like an innocent array can store, if we use that as a numerical, we'll look at it as a numerical, I don't know what. Yeah, so as a numerical, because just 2000 values in an array is, it's not that much, but when you think of it as a numerical, it becomes a huge number. It's probably, I think I heard that 2 to the power of 500 is bigger than all the particles of visible universe. So that thing is even like, that's a astronomical number, but that's fine. What that suggests, that trying to okay, so but let's back to the brute force. I was detouring, and now I'm segueing. Yeah, detour meaning detour means a different, less direct route. So yeah, I'm detouring to the brute force solution. So we could start with 0, 0, 0, and so we have that, and see if the pair is going to be so that's non-decreasing, and we can try and see if the pair is going to be non-increasing. In this case, it's basically the input array. Ouch, my knee hit it on some kind of thing under the table. And in this case, it's not gonna match, so we're gonna not count this pair. And then we'll go to the next one, will be 0, 0. Because I mean, generating monotonically non-decreasing is kind of, I think it's kind of easy. Because I mean, we can just go to the last value, grow it until the limit. The limit will be the input value, and then all the other ones, the next one will grow where the limit will be the number to the next, because it has to be. Oh, wait a second! It has to be so it's because we have to have something like that, so it can. The previous one cannot be bigger. Okay. But we can generate this, and that exercise, generating these, the pair, the what do you call array R1, array one will be already this big of an exercise. How many reps? Yeah, it's gonna be this number of reps. It's gonna be this number of reps. Yeah. Why? Because, is it so? Is it so? Well, for every Is it so? Yeah, so because we'll do yeah, 2 of these, then we'll do so that didn't work. That that was, so that was 2, 3, 2. That would be 2, 3, 1. And we'll have a decreasing, but this has to be non-decreasing. And only when we get to 0, 0, 1, 1, right? Oh, wait a second. No, we wanted to do the 2 first. Why do we want to do 2 first? I mean, it's one way to do it, but we can, yeah, I mean, get that to the maximum. That will be 2, 3, 0. So that's another decreasing. And then actually, I think, yeah, I think more, it will be more logical to do 0, 1, 1. So yeah, we'll increase by 1 because everything by 1. Then we'll do that will give us the value of the 2, 2, 2, 1. 2, 2, 1. Now non-increasing. Okay, this is the first non-increasing, yeah. Okay. So this is not gonna work and like that. But basically, even for this example, there will be, yeah, because there will be 2, then somehow my method suggests it will be, in this case, roughly 2 to the power of 3. Because, and we can show it in a smaller example, but that's how it is. Yeah, if the input is 2, 2, then the variations are gonna be 0, 0. So there will be 0, 1. Yeah, so this 2 is either 0, it will be 0, 2. So there's actually 3 because it's 0, so it's 3 to the power of 2. 3 to the power of 2 is 9. So we'll get then. So, and then for each of these, so for 0 we have 3, for 1 we have, and for 2, yeah, so that's why we get this astronomical number, because for each there will be a combination. I mean, that quickly suggests it's not a logical solution. I'm overthinking it here just randomly. But I mean, iteratively, brute force is gonna take forever because a billion values is a second. But I mean, we can, so the basic, I mean, that's not all. We need to generate the pair 1, and then we calculate the pair 2, and then the pair 1 was, and then we check the pair 2 if it's monotonic, if it's monotonically increasing. Yeah, because the pair 1 we can make sure it's monotonically decreasing. It's non-decreasing, monotonically non-decreasing. Yeah, but the next value to check the array 2 need to check that condition that it's non. Yeah, as a brute force, but I mean, there are probably a more optimized way to do that instead of just building the value and then do the iterative check. So we probably could know from the get-go as we generate the non-increasing, the first array, the non-decreasing, let's say we look at this, this case, for example, because at that point we can say, okay, it will be 2 on the second one. Then we'll have the 0 here, and we'll say which is non-decreasing for the first one, and we'll look at the second one and we'll compare it with the previous value, and we'll see, okay, it's decreasing. Oh, it's increasing, but it has to be non-increasing. So we can skip that all at once. And I mean, 0, 0 is not going to work here. Immediately, we can tell that. Well, how immediately? I mean, we might, for each value, it's in its order when we find that out. But I mean, so we can stop going further. So basically, it's a each operation, it looks like, of generating a candidate. So generating a candidate is a linear operation. It's a linear operation to generate that candidate. Okay, I have a minute. I need to drop. I need to get to the meeting. But basically, we come to the point where the linear, we can't do linear this number of times. It's too long. It's gonna be like, woo, how long? It's gonna be like, I don't know, ages probably. Because, so to 10 to the power of 9 is a second, okay? And we're gonna have, I don't know, it's not like 200 seconds, no. I don't know, it's hard to tell. But okay, back to it's a good question, by the way. Yeah, good question, but I need to drop off. Yeah, so stop sharing and streaming, and